Okay, in this video we're going to solve analytically using the definition of derivative, so let's go ahead and start. The learning goal. Students will be able to use the definition of a derivative. Okay, so I'm going to have a couple of complicated, well, not too complicated functions, but we're going to do the same thing as the last video and use the definition of a derivative. So we're going to be solving analytically. Remember that analytic means using algebra or calculus, and kind of to drill it in your head, the derivative simply is just the slope of a tangent line to a curve at some point. So let's go ahead and scroll down and take a look at our first example. Now, before we hit our first example, it looks like we have, just to review, the definition of a derivative. It's basically the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Remember that different textbooks have different names for delta x. They could have put a h there for small change. So don't be scared, it's just the same formula. We also have the three formulas that we saw in the last video. So that's where they replace delta x with h. The next one is limit as x approaches c of f of x minus f of c all over x minus c. And the last one we don't use as much. It's a lot of work for this one. It's the limit as h approaches 0 of f of a plus h minus f of a minus h all over 2h. And it's hard to say as well. Okay, so in this problem, they want us to use just the traditional definition of a derivative. That's perfect. And they want us to show the first derivative of sine x. So this is going to be a little bit of work. I actually gave you a hint. We're going to have to basically dive back into our tool bag of pre-calc and basically use the sum property that says sine a plus b is equal to sine a times cosine b plus cosine a times sine b. And we're also going to have to use another theorem that I showed you in earlier videos. It looks like this. Limit as x approaches 0 of sine x over x, and if you recall, that's equal to 1. So we're going to use this, and one more tool, number 3. Limit as x approaches 0 of 1 minus cosine x over x, and that generates 0. So with these three tools, we're going to be able to hopefully find the first derivative of sine x. So let me grab Mr. Green and then we'll give it a go. Alright, so I'm going to plug into the definition of a derivative. The definition in this case looks like this: the limit as h approaches 0 of f of x plus h minus f of x all over h. And so if I do that, I basically get this: limit as h approaches 0 of sine x plus h minus sine x all over h. And this is where our number 1 trig formula comes into play. So I need to expand this out, because remember, the goal here is to try to simplify this down so I can get rid of the denominator, because as is, I end up getting 0 over 0. So the way that's going to look is this: limit as h approaches 0 of sine, and it's going to be x times cosine h plus, and it's going to be cosine x times sine h minus sine x all over h. So I just used that number 1 formula. Okay, so next up, what we want to try to do is we want to try to see if we can find a way to rewrite our limit into these two theorems. So let's see if I can do that. Because we know what this is equal to. It's equal to 1. And we know what this is equal to. It's equal to 0. So let me go ahead and grab Mr. Red. Okay, this is a little bit more complicated, so bear with me here. So if I have this over h, I can try to get it to look like number 2. I can try to write sine h over h, and then hopefully it'll equal 1. Don't worry about the cosine. That I can take out because it's multiplication. Let's see if I can generate the third one. So if I grab Mr. Blue here, alright, if I have this minus this, I think I can do it. Now I know it's crazy. It's like one of those videos, or it's like watching a football game. Someone's writing all over the screen on the players. I understand it's a little bit complicated, but just trust me. I can try to create this actual theorem. So let me go ahead and let's just dive in. Let me grab Mr. Red so I can color code. Limit as h approaches 0. So I'm going to say, okay, I can split this into cosine x times sine h over h, and I can. And due to properties of limits, I can also say this, plus, and then let me grab Mr. Blue, limit as h approaches 0 of sine x times cosine h minus sine x all over h. Okay, that's legit. I can do that. Alright, so in red, wouldn't you agree that this would be just simply this piece and this piece would make 1? So you end up with cosine x times 1. In blue, I need to do a little bit more work. So I'm going to write a plus here. Limit as h approaches 0. Okay, if I factor out a sine x, I get this. Cosine h minus 1 all over h. However, for the formula, or for the theorem that is, I need 1 minus cosine h. So what I'm going to have to do here is I'm going to have to distribute out a negative 1 if you will. Okay, now I have the formula. And remember, the formula for this is simply just 0. So I get basically, if I rewrite this, cosine x plus negative sine x times 0. So that just makes 0. And I'm left with the first derivative of sine x is cosine x. Wow, I'm proud of you guys. That was a tough one. Okay, let's go to the second example. It's going to be a little bit challenging as well, but not as crazy as the last one. Okay, so they want us to take the first derivative of x cubed. No worries, let's start. Limit as delta x approaches 0 of, in this case, x plus delta x cubed minus x cubed all over delta x. Okay, I need to expand this, so I'm going to have to use Pascal's triangle. So let me go up here and do it. 1, 1, 1, 1, and then it's going to be 2, 1, and then finally 1, 3, 3, 1. Okay, so how Pascal's works is this. I basically take the first term and raise it to the highest degree, which is 3. So x cubed. And then take the second term and raise it to the lowest degree, times delta x to the 0 power. Plus, okay, then this number decreases and this number increases. So x squared times delta x to the first plus x to the first times delta x squared plus x to the 0 times delta x cubed. Okay, we're in good shape. Let me go ahead now and rewrite this. Limit as delta x approaches 0. And then if I simplify a little bit, I get x cubed. I'm just simplifying this right here from algebra 2. Plus 3x squared times delta x plus 3x times delta x squared. And then finally I have plus, in this case, delta x cubed minus x cubed, and I just brought that down from there, all over delta x. Whew. Getting a workout. Okay, so we're almost there. If I plug in a 0, unfortunately, I get 0 over 0. So let's see if anything cancels out. The x cubes are gone. They cancel out. Anything else? Unfortunately, no. However, the nice thing is they all have delta x in common, so I can factor one out. So limit as delta x approaches 0 of delta x times 3x squared plus 3x times delta x, and in this case plus delta x squared all over delta x. Those cancel out, and then if I evaluate my limit, I end up just getting 3x squared. This goes to 0, this goes to 0. So the first derivative, so if I have f of x is equal to x cubed, the first derivative would be f prime of x is equal to 3x squared. Alright, so that's all the time we have. Let's see if we hit the learning goal. Students will be able to use the definition of a derivative. I truly think you'll be able to do this. I'll see you in the next video.